this is Chemnoel. We're on channel QT, and here's another installment of Just a Safety Minute. Hello, in this episode, let's talk about radioactivity terminology. So many terms, so confusing, and to make matters more complicated, the world is changing from legacy units to SI units. So first, how much radiation do we have? Well, if we could picture a bucket and put water in it, we know how to measure water in a bucket, but in radiation, we measure in terms of activity. In other words, how fast are the clicks clicking on your meter? The unit we use for that is called the Curie, which is the legacy unit, or the becquerel is the new SI unit. But what we really care about is how much is absorbed into you. Okay, we were just talking about amount of radiation in our bucket, but we need to head outside and find a reluctant victim, so we're on the prowl. In the early days, the unit Rankine was used to measure how much air is ionized by X-rays or gamma rays, but human bodies don't ionize the same way as air. I know, shocking. So a new unit had to be developed. That was the RAD, or radiation absorbed dose. In other words, how much energy is absorbed into your body when you're exposed. But not all tissues are created equal, so another unit was needed, the REM, radiation equivalent man, or sometimes Rankine equivalent man, and that accounts for the difference between absorption rates between different tissues. And for emergency response, when we have gamma rays or beta particles, we think of RADs and REMs as the same thing. If you're dealing with alpha particles, be sure to consult with a health physicist or your local health department, because you can have much higher level in terms of REMs than RADs if you're dealing with alpha particles. We also need to talk about RADs and REMs. Those are legacy units. For RADs, the new SI unit would be grays, and for REMs, we would use the term sieverts.
What are you doing? Seriously?
Okay, let's imagine the amount of water in a bucket as our amount of radiation. We would measure that in curies or becquerels, and then let's imagine all of that flying out of the bucket. Not all of the water will hit our victim, so the amount that actually hits the victim, we would think of that as a measure of rads or grays, and then not all of the water will stick to the victim. The amount that does stick, we would imagine measuring that in REMs or sieverts.
Oh my god. Seriously?
Remember our protection factors, time, distance, and shielding. If our victim had a shield to put between himself and the bucket, he could have been protected. If he could have run away much faster, increased his distance, he would have been protected. Then the other factor would be time. If the water was dribbling out of the bucket, he would have plenty of time to stick around and have a minimal exposure. But when the water comes out very fast, his time is very short to keep a minimum exposure. Okay, well, thanks for watching. Be safe out there, and remember, chemistry's fun.